Good morning, students. In the last class, we discussed about population. We also covered sampling methods, variation, and sampling error. Today, in this class, we will discuss more on the sampling error, and then we will cover confidence interval, and then we will also look at ideal method to determine the sample size. Let's refresh what we saw in the last class. A population, it is really going to be huge. All the data points that I'm planning to study is referred to as a population, and it is denoted by capital letter N. And a sample is going to be a subset of a population. It is denoted by small letter n, and I can't use population because I need to spend more amount of money to measure all the data points in the population, and it will take a lot of time for me, and then it will also consume a lot of resource. So these are all the drawbacks because of which I may not be able to use the population. So the workaround for that is to take a sample from the population and measure it, and then infer the population parameter. But when I take the sample, I have drawbacks in terms of bias or favorism, and the next drawback would be in terms of sampling error that we have. These are all the drawbacks related with sample. Now we discussed about the different sampling methods. I think we covered 5 different methods in the last class. We covered simple random sample, and then we looked into systematic sample, convenience sample, and then we also covered stratified sample and then clustered sample. Correct? So 1, 2, 3, 4, 5. Yes. So these are all the 5 different sampling methods that we covered in our last class. We looked at variation. We looked at the different. We discussed about what variation is, and then we also discussed about what explainable variation is. We discussed about natural and explainable variation, and then we discussed about sampling error. So what a sampling error is, correct, in our last class. So let's further discuss on this last concept, which is called the sampling error. So like I told you before, we will not be able to measure all the data points in the population, so you will definitely take a subset from the population and study it. Now when you are considering a subset, you're not taking all the 100% data points, correct, and because of that you are bound to have sampling error, and this sampling error will definitely be there in all the scenarios, no matter what we do. The reason is we're not able to study all the 100% of the data points from the population. Because of that, the sampling error is bound to happen, and whatever mean value that determined by using the sample will definitely differ when you compare it with the population mean. Okay, and the deviation or the difference that you see between the sample mean and that of the population mean is nothing but your sampling error. Okay, and what is happening here is that let's say that I have this as my whole population. Okay, and then what I'm doing is I'm just taking a subset, and then this is my sample, correct. I'm studying this and I'm forming some statistics. It could be mean or standard deviation, and then what I will do is that I will use this and infer the population parameter. So this is the actual process of sampling, wherein I will have my whole population, which will have millions and millions of records. I can't study the population, so I take a subset and form my sample, and then I will study the characteristics of the sample, and then I will determine the mean and standard deviation, which are nothing but the statistics for the sample, and using that I will infer the population parameter, which could be your mean, standard deviation. So what is happening here is when I look at the sample, when I get the statistics using the sample, the number that I get will not tie up with what I have in the population. Let's say that I'm considering I'm forming a sample S1 having 5 elements in it. Okay, I'm forming S2, which is another sample having a different 5 element in it. And S3 is again formed having the same size, but it has got different elements in it. Now the sample S1 might have given you a mean of 10, and the sample S2 might have given you a mean of 15, and the sample S5 might have given you a mean of 25. Okay, and if you look at the population mean, the mean for the population, okay, so it could be 13. Okay, now using these three values which I got from the sample, how is it possible for me to infer the population parameter, which is nothing but the mean of the population, which has got a value of 13? It is highly impossible. I get inconsistent result from the samples. The reason why I'm getting the inconsistent result is very simple, because the elements which goes into the sample are different. It is not the same element, and also it is not 100% representation of my population. Unless and otherwise I consider all the data points, I will not get the population mean. Okay, so this sampling error is bound to happen no matter what I do. But how do I reduce it? Correct? How do I address this? How do I infer the population parameter with confidence? That is what we're going to discuss in this particular class. Okay, now the values 10, 15 and 25 which I got using the sample S1, S2, S3 are point estimates. So this value, and this value are nothing but point estimates, which means that they're sharply denoting a particular number. And what I'm trying to do is I'm trying to measure something which is unknown using point estimate, which is a wrong method to apply. It's always good when you're trying to express certain things which you're not sure in a range. For example, if you're appearing for an exam, you would say that I might get between 80 to 90%. Correct. So here what you're specifying is that you're specifying a range. This is a much safer way of expressing how much mark you will get, rather than you saying that I will exactly get 85% mark. You're not sure, you don't know how much you're gonna get. This is just that, like, based on how you wrote the exam, based on the type of questions that you got, based on how you answered it. Correct. So you give a range, right? This range is always good when you're trying to express certain things which you're not sure or which you're not confident. Correct. So what we need to do is, in the above scenario, right, instead of having, instead of expressing the sample mean as 10, 15, 25, if you express something like the mean is going to be 15 plus or minus of 10, which means that you need to add 10 to 15 and then you have to subtract 10 from 15, which implies that this is going to have a range between 5 to 25. And when you have this particular range for the mean, your population parameter, which is nothing but the population mean, definitely falls in this particular range. So this is definitely going to help us, because this is definitely this will definitely ensure that my population parameter will fall within the range. Okay, so basically when you are trying to make use of your sample statistic, and when you try to measure or express your population parameter, you need to express that in a range, instead of giving a point estimate. Okay, this range that you're talking about here is nothing but your margin error. The plus or minus, anything that you see after plus or minus of 10, this is called as margin error. This will take care of this margin error, takes care of the uncertainty which comes to the picture because of sampling. Okay, so let me refresh you what I was informed, what I shared with you in this class. One is that the population is going to be huge, so you will just take a subset and then you form the sample and then you determine the statistics of the particular sample, and after that you infer the population parameter. Okay, and this is the normal sampling process that we follow. Now since you're taking a subset And since you're not measuring all the 100% data points that you have in the population, you're bound to have sampling error. Different samples with different elements will give you different observations. Okay, like here sample S1, S2, S3 have given you 10, 15 and 25 as mean, and these three means are nowhere related or matching with the population mean, which is 13. The reason being, we're not measuring 100% data points, we're just taking a subset, and these subsets have different values which goes into it. So instead of giving a point estimate like 10, 15, 25 for inferring the population parameter which is unknown, we have to give a range. We have to factor in the error, and then we have to express the population parameter. Okay, so that's what we have done here. So this, the 15 here would be your sample mean, plus or minus of 10 represents the margin error, and this translates to 5 to 25 will be your population mean. And if you look here, this particular number or range which you determine using the sample statistic ensures that your population parameter lies within it. Correct? So this is what we have to do when you are trying to infer certain things which you are not confident about or which you are unsure about. Now that's okay. In fact, there is one problem which got rectified, which is I'm not using point estimate. Okay, I'm not using a point estimate, but I'm using a range. Okay, basically, like I'm specifying the margin error, which is going to have plus and minus sign associated with it, and this margin error will factor in the unknown variations or the error which gets associated because of using the sample. Okay, the margin error ensures that I get a range of values, right? And this margin error is nothing but a set of values above and below your mean. Okay, plus and minus or some values above and below the mean, which is going to be 15. Okay, so we have formed mean. We have formed the range, which is right. But do I have the confidence? I still don't have the confidence, because when I use a different sample, I get different value. Correct? I still don't have the confidence. So how do I address that? So that's why we have something called confidence interval. Okay, confidence interval commonly used values are 90%, 95%, and then you have 99%. These are all the common values which gets used for confidence interval. So let me tell you what confidence interval is all about. Okay, confidence interval is basically a probability. Okay, it talks about the probability that your population parameter, it is a probability. Remember that this is a probability wherein your population parameter will fall between two sets of values. Falls between two values for certain proportion of time. Okay, so basically what a confidence interval is, it's a probability that will see to it that your population parameter, okay, this is important, the population parameter falls between two values. Okay, and those two values are going to be your plus and minus values that you got, okay, for a certain proportion of a time, which means that if it means that, let's say that my confidence interval is 90%. What I'm implying is, out of 100 times, okay, out of 100 times, 90% of the time, I would be able to get a population parameter which will fall between two values which I got by using my margin error. Okay, and this is going to be like 90% of the time. Okay, or else what I can say is that out of 100 times when I take different sample from the population, 90% of the time I will get the same value, and the value is found to lie between the two values which is set by the margin, error margin. Okay, and I can use that for inferring the population parameter. Is that clear? So basically what I'm trying to say is this confidence interval ensures that whatever value that I get whatever value that I get by measuring my sample statistic could be inferred for the population parameter with confidence. I don't have to worry about it. Okay, so irrespective of number of times, okay, like if I say 90% confidence, it means that let's say that I'm taking 100 different samples from the population and I'm measuring and I'm getting 100 different statistics. Out of those 100 different statistics, 90% or 90 different samples will ensure in the 90 different samples I will get the same value, and the value that I got will definitely lie between the range which I got using my margin error. Okay, so this is what a confidence interval is. Okay, so this is also an important. Okay, so what we have seen here is, first is we looked into margin error, because we will not use point estimate because there is an uncertainty which has to be addressed. And the second is confidence interval, okay, which is important because I want to infer my population parameter using sample statistic with confidence. I should not have any kind of a doubt, right? So that's where this confidence interval comes into picture. A confidence interval of 90%, it means that out of 100 samples which I have taken, in 90% of the samples, no matter how many times I repeat, I will get the same value, and the value will lie between the two values which is set by the margin error for the population parameter. Okay, so this is what a confidence interval is all about. Okay, so now let's go to the next particular topic that I plan to discuss here, which is with regard to identifying the right sample size. Okay, identifying the right sample size is also important because, like, if you take a sample which is too less, you will get something which will not be the right representation of the population, and then your results are going to be skewed and they are going to be biased, right? So identifying the right sample size is also important. Now, how do you identify the right sample size? What are the steps involved in it? I have listed it down here for you. And the first and foremost step is that you need to identify. You have to clearly define the population. Okay, the population has to be clearly defined. It has to be properly quantified. That is important. Okay, the first step is population quantifying or defining. Okay, so you need to define the population in a very clear statement, and you have to quantify it. And the next step would be to specify the margin error. We know what a margin error is. Basically, this is the tolerance level. It means that I'm okay. Let's say that, like, there are about 1,000 bulbs get manufactured, out of which like 1 or 2 is defective. I'm okay with it. I'm okay to get 2 defects out of 1,000 bulbs that gets manufactured. That's my tolerance level. Likewise, like when you start measuring the data, since you're using a sample, you're bound to have some error. Okay, and that error has to be quantified. That has to be factored in. That gets factored in by using the margin error. Okay, and it basically talks about the deviation of the sample mean from the population mean. How, to what extent are you okay to have your sample mean differ from the population mean? Okay, after you specify the margin error, then the next thing is that you need to specify the confidence interval. We just now discussed about the confidence interval in detail. It basically it's a probability for you to get the population parameter to fall between two set of values for certain specified amount of time. Okay, so that is what your confidence interval is. Okay, basically, again, I'm reiterating, if I have 100 different samples which I'm taking from the population, out of those 100 samples, if my confidence interval is 90%, it means that in the 90% of the samples I get the same value, and this value will fall between a specified set of values. Okay, and I can use this to infer my population parameter. Okay, that's your confidence interval. And the fourth step is that you need to specify the standard deviation. Okay, like if the standard deviation is not specified, then you can take a default value of 0.5. Okay, now if you have all these four defined, then you would be able to determine your sample size. Okay, and there are two different formulas which you can employ, which you can use to determine your sample size. One with population and other for without population. So there are two different sets of formulas that we have. By utilizing it, we will be able to determine the sample size. And like I said, there are four different steps. One is you have to define what your population is, you have to quantify it. And the next thing is that you have to mention your error margin or margin error, and then you have to specify the confidence interval. You can have different confidence interval. The commonly used are going to be 90%, 95%, and 99%. Okay, and then the standard deviation has to be specified. If the standard deviation is not specified, then you can take a default value of 0.5. Okay, and I have just written down the formula over here. There are two different buckets that you can see, right? One is that when the population is known, and when the population is not known, and the sample size is given by z square into p into 1 minus p divided by e square. Here z is your z value. Okay, z value you can get it from z table, and this is dependent on the confidence interval that you are selecting. Okay, so this is something that we will discuss more in the next chapter or in the next class. So there is a z table which will give you the z value corresponding to the confidence interval. I have made a note of the z values corresponding to the confidence intervals of 95% and 90%. Over here, since we are selected 95%, we will be taking 1.96 into account. Okay, and you just have to substitute the values. Okay, like it's you have to plug in the values, and then you'll be able to determine the sample size. Since we selected the confidence around 95%, we will get the z value as 1.96. So this is taken care. This is taken care. P is your standard deviation, which I said that as the default is going to be like 0.5. This is also taken care, and e square is your error margin or margin of error. Okay, since you are taking 95% as your confidence interval, the error margin is going to be 5%. Okay, and then you just have to plug in the values, and then you'll be able to get your sample size. Okay, and the formula for in terms of determine the sample size when the population is slightly different. Okay, again it involves the same variables. The variables, there is no addition of a variable which is difficult to interpret. Okay, here what we have done is we have brought in the sample size into account. Okay, so basically here, since the population, since the size of the population, you can plug that in. Okay, n is your population size. Okay, and the rest are all going to be like the values that you discussed earlier. When you substitute all these values, you will get a sample size, and that is something that you have to factor in when you form your sample. Okay, and please ensure that you can take anything which is above the sample that you get here. You can exactly take 196 or 197. You can even take anything which is more than this, but it's important that you don't drop below this particular value of 196. Okay, ideally this would be the ideal scenario, or the statistical way by which you will be in a position to explain people when they question you, like how this has been done, and what is the sample size that you have selected, and why it has been done like this. Correct? Rather than you randomly or guessing and then going with some number, you would be able to put forward your statement and argument saying that why you have taken so much as your sample size. Okay, so this is what I had planned to discuss in this class. I think that we covered all the topics which I have listed over here. Okay, and this is something that you can read through what I have put in here. These are all the notes which I have written. Okay, so which you can read through. I have also given you an example and I have explained it to you. Basically, like, whatever definition that we discussed, right? The same thing, gets. I have written it down and I have interpreted in a simple way. So that's all for today in this class. Thanks for listening to this class, and we will again catch up next week, and we will see further topics that we have listed down in the main section. Thank you guys, and have a wonderful day.